Welcome to 3D Online Tuition. It is a three-dimensional e-learning method based on audio, visual, and event.
Yippee! Yay!
Chapter 6. Sources of Energy. 6.1. The various forms and sources of energy. 6.2. Renewable and non-renewable energy sources. 6.3. The importance of conserving energy sources. 6.1. The various forms and sources of energy. 1. Energy is the ability to do work. A thing is said to have energy if it can do work. 2. The unit to measure energy is called joule. J.
1 joule equals 1 kilogram meter square per second square equals 1 Newton meter.
3. There are many different forms of energy, which in general can be categorized as working energy, stored energy. Forms of energy. Working energy, kinetic energy, heat energy, electric energy, sound energy, light energy, stored energy, potential energy, chemical energy, nuclear energy, kinetic energy.
When an object moves, it have obtained kinetic energy. The faster the object move, the bigger kinetic energy it contained. When two objects moving at the same speed, the object with a greater mass contain more kinetic energy than the lighter object. A stationary object contains zero kinetic energy. Kinetic energy depends on mass, m, and speed, v, of the object. Kinetic energy equals half time m time v squared.
Heat energy.
Any heated object contained heat energy. The hotter the object, the greater heat energy it contained. When two objects make up from the similar material, but with different volume, are at the same temperature, the object with a greater volume contained more heat energy than the smaller object. Heat energy depends on the speed of the particles, associated with temperature, the number of particles, the size or mass, and the type of particles in an object. Our sun is the main source of heat energy.
Electric energy.
Electric energy is the energy carried by an electric current. Electric current produced when electric charges moves through a conductor or wire. Electric energy can be mass-produced by generators in fossil fuel power plant, hydroelectric power plant, and in wind turbine. It also can be produced directly from the solar panel. Electric energy is very important and useful to our modern society, because electric current can be produced, transported, stored, and transformed it into other form of energies easily.
Sound energy.
Sound energy is produced when an object vibrates. Sound energy travels in the wave form, through solids, liquids and gases by the vibrations of the particles. Sound energy travels the slowest through gases, faster through liquids, and fastest through solids. Sound energy cannot travel through vacuum, because there are no particles in the vacuum that enable energy transfer.
Light energy.
Light energy is the energy emitted by a luminous object. Light energy travels in a wave form. But unlike sound energy, light energy can travel through vacuum, because it does not need any particles to carry its energy along. Our sun is the main sources of light energy.
Potential energy.
Potential energy is the energy stored in an object because of its position or condition. Gravitational potential energy is a stored energy possessed by an object due to its position from the ground. The higher the object is raised above the ground, the more gravitational potential energy it contains. Elastic potential energy is a stored energy of stretched or compressed object, such as spring. Energy is stored and ready to be released when a spring is stretched or compressed.
Chemical energy.
Chemical energy is the energy stored in a substance such as foods, fuels, and batteries. When a substance encounters a chemical reaction, its stored chemical energy will be released and transferred to another form of energy. When foods is break down inside our stomach, through the digestion process, energy is released to enable us to do our daily activities. When fuels such as coal and petrol burn, heat energy and light energy are released. Chemical energy stored in the battery can be converted into electrical energy.
Nuclear energy.
Nuclear energy is the energy stored in a nucleus of an atom. Nuclear energy is released into many forms, such as heat, light, sound, and radiation rays. Nuclear energy is released during the nuclear reaction process, such as nuclear decay, nuclear fusion, and nuclear fission. Nuclear decay is a process when an unstable radioactive substance loses its energy by emitting radiation rays and heat. Nuclear fusion is a process when lighter elements, such as hydrogen, is fused together to form a new and heavier element. Nuclear fission is a process when heavy elements, such as uranium, is broken down into lighter elements.
Energy changes. The law of conservation of energy, or the first law of thermodynamics, stated, "The amount of energy and mass in the universe is constant," also mean, the total energy of an isolated system remains constant. Energy cannot be created or destroyed. Energy change from one form into another.
Rubbing hands.
Kinetic energy of hands movements change to heat energy of hands feels warm.
Clapping hands.
Kinetic energy of hands movements change to sound energy of clapping sound.
Lighting up a light bulb with dry battery.
The energy changes are chemical energy of dry battery change to electrical energy of current flow in the circuit change to heat energy of heat from the lighted bulb plus light energy of the lighted bulb.
Measuring electricity of a potato.
The energy changes are chemical energy in a potato change to electrical energy of current flow in the circuit change to light energy of the display on digital multimeter.
Release a compressed spring.
The energy changes are potential energy of the compressed spring change to kinetic energy of the spring released back to its original.
Rocket takes off.
The energy changes are electrical energy of rocket battery for rocket engine ignition plus chemical energy of rocket fuel change to kinetic energy of rocket up motion plus potential energy of rocket left ground plus light, heat, and sound energy of the rocket exhaust plume.
Cycling up and down a hill.
When the cyclist cycling on the flat land, kinetic energy is at maximum, and potential energy is zero. When the cyclist cycling uphill, he slows down. Kinetic energy is losing, and changed to potential energy. At the top of the hill, if the cyclist stops cycling, all the kinetic energy will now change to potential energy. When the cyclist go downhill, the potential energy, starting to change to kinetic energy. When the cyclist reached flat land again, all the potential energy will change back to kinetic energy.
Juggling balls.
When the ball left the hand, the kinetic energy is at the maximum. As the ball rises, it slows down and lost kinetic energy. The lost kinetic energy is changed to potential energy. When the ball continue rises, more kinetic energy changed to potential energy. At the highest point of the juggling, the ball stopped momentary, before falling down. At this highest point, the potential energy of the ball would be the maximum, and kinetic energy becomes zero. When the ball starting to fall down, it pick up speed. The potential energy now changed to kinetic energy. When the ball continue to fall down, more potential energy changed to kinetic energy. When the ball fall back to the hand, the ball stop. All the kinetic energy now change to potential energy. The sources of energy.
Fossil fuels.
1. Fossil fuels include coal, petroleum, and natural gas. 2. Fossil fuels is formed from decomposition of buried dead plants and animals of the ancient time over a very long period of few hundred million years. 3. Petroleum normally found under the seabed or on land, whereas used to be an ancient seabed. 4. Natural gas consists of a mixture of primarily methane and varying amounts of butane, ethane, and propane gases. It normally found near the petroleum deposits. 5. The advantage of natural gas over petroleum are, it contains more heat energy, and produced less soot. Natural gas mainly used as cooking fuel, and fuel in power plants to generate electrical energy. 6. Coal, formed from the remains of dead trees, buried in swampy areas around 300 million years ago. Coal used in power plant, and home heating in the cool countries. However, coal can pollute the environment, because it releases a lot of soot and toxic gases.
Biomass fuels.
1. Biomass is organic materials include wood and agricultural products, municipal solid waste, garbage, organic waste from animals and humans, feces, landfill gas and biogas, alcohol fuels, ethanol, and biodiesel, derived from industrial residues. 2. Biomass can be turned into biomass fuels. The solid biomass, such as wood and garbage, can be burned directly to produce heat, whereas others biomass can be processed into biogas or liquid fuels, such as ethanol and biodiesel. These fuels can then be burned for energy. 3. The advantages of biomass fuels over fossil fuels are: biomass fuels used as a fuel can reduces the need for fossil fuels for the production of heat, steam, and electricity for the residential, industrial, and agricultural use. Biomass fuels produces less harmful greenhouse gases and carbon than fossil fuel. Biomass is always available and can be produced as a renewable resource.
Water.
1. Water energy is energy derived from the power of flowing water, or kinetic energy of water. 2. Hydroelectric is electricity generated from the flowing water. Hydroelectric power plant uses a dam on a river to store water in a reservoir. When water released from the reservoir, it flows through a turbine. The kinetic energy of the water will spin the turbine, which in turn activates a generator to produce electricity. 3. The energy changes are: potential energy of water at reservoir, change to kinetic energy of water flowing down to the turbine, change to electric energy. 4. Hydroelectric is considered as renewable energy and contributed around 70% of all renewable energy in the world.
Wind.
1. Wind energy is energy derived from the power of blowing wind, or kinetic energy of wind. 2. Wind energy produce electricity from the blowing wind. Kinetic energy of the wind spins the blade of the wind turbine, which in turn spins the turbine and activates a generator to produce electricity. 3. The energy changes are: kinetic energy of the wind that spins the blade, change to electric energy. 4. Wind power plant produces no air or water pollution, and since the wind is free, operational costs are nearly zero once a wind turbine is erected. However, wind is also variable. If wind is not blowing, there's no electricity generated.
Waves.
1. Waves energy is energy derived from the power of waves, or kinetic energy of waves. Waves created when wind blowing across the surface of the sea water. Waves has both potential and kinetic energy. 2. Wave energy can be used to generate electricity. We can convert the vertical movement of the surface water that produce tidal waves to the periodic up and down movement that can activate a floating generator buoy, which is placed near the surface of the sea, to produce electricity. There are currently many different types of design, and concept of the generator buoy has been developed to capture this up and down movement of the waves to produce electricity. 3. The energy changes are potential and kinetic energy of the waves up and down movement, changed to electric energy. 4. Wave energy is unique, because it is the most concentrated form of renewable energy on Earth, with power density much higher than that of wind and solar energy. Waves are also more predictable and consistent than wind or solar.
Tides.
1. Tidal energy is another form of hydropower that converts the energy obtained from tides to generate electricity. 2. Tides are periodic rises and falls of large bodies of water, caused by the gravitational interaction between the Earth and the Moon. The difference in the height of water during high tides and low tides can be used as the main principle to generate electricity. Tidal barrage is one of the tidal power generation using this principle, which acted like a two-way hydroelectric dam. 3. The energy changes are potential energy of the water at high tide, changed to kinetic energy of the water flowing down to the turbine, changed to electric energy. 4. The limitation of tidal energy is that it requires a suitable site where the tides and tidal streams are consistently strong. This make only a handful of sites are available to extract such energy.
Geothermal.
1. Geothermal energy is the heat from the earth. Resources of geothermal energy range from the shallow ground to hot water and hot rock, found a few miles beneath the Earth's surface, and down even deeper to the extremely high temperatures of molten rock, called magma. 2. Geothermal power is power or electricity generated by geothermal energy. Water or working fluid is heated by the geothermal reservoirs, or steam directly from the geothermal reservoirs are sent through a steam turbine, where the thermal energy is converted to electricity by a generator. 3. The energy change are heat energy of geothermal reservoir, changed to kinetic energy of steam turns the turbine, changed to electric energy. 4. Geothermal power is considered to be a sustainable and renewable source of energy, because its source is the almost unlimited amount of heat generated by the Earth's core.
Radioactive.
1. Nuclear energy comes from radioactive substances such as uranium and plutonium. Nuclear energy is not a renewable energy. 2. Heat can be harnessed from splitting atoms in a nuclear reactor to heat water into steam, turn a turbine and generate electricity. 3. The energy change are nuclear energy of splitting atom, changed to heat energy of steam generation, changed to kinetic energy of steam turns the turbine, changed to electric energy. 4. Despite nuclear power plant poses potential threat to the environment and human life, it is a very important future energy source. Generating electricity in nuclear reactors is not only emitted less greenhouse gases, it actually cheaper than electricity generating from oil, gas, and coal, not to mention the renewable energy sources.
The sun is the primary source of energy.
The sun is a huge, glowing sphere of hot gas, made up primarily of around 72% of hydrogen and 26% of helium. The sun gets its energy from nuclear fusion, where two atoms of hydrogen combine together, or fuse, to form an atom of helium. This nuclear fusion process releases an incredible amount of energy, in the form of light and heat. When the light energy of the sun reaches Earth, it will help in the photosynthesis process, in the plants, to convert the sun's light energy into chemical energy, that's stored as foods, in the plant. Human and animals consume the foods made by plant, for their own survival. Heat from the sun warming up our planet, and allow liquid water exist on the Earth's surface. Over 70% of our planet is covered by water. Heat from the sun also make water evaporates, to form clouds. When cloud condenses, and cool down, it fall back to the ground as rain. Falling rain over period of time created lakes, and rivers. When the sun heats different part of the atmosphere differently, it created different pressure amongst these areas. The motion of air, from the high pressure area to the lower pressure area, creates winds. When winds blows across the surface of the sea, wave created. We can harness all these different forms of energy, which are originated from the sun. We can build wind turbine, to capture the kinetic energy of the winds, and convert it into electricity. We can build hydroelectric power plant across the river, to capture the potential, and kinetic energy, of the water in the river, and convert it, into electricity. We can place array of floating generator buoy at the sea, to capture the up and down movement of the wave, to produce electricity. We can also utilize the energy directly from the sun, such as building solar power plant, to extract solar light energy directly, and convert it to electricity. The heat energy from the sun can be used directly without energy conversion in the solar water heater, to generate hot water for the bathroom or kitchen use. After the plant and animals died, their remains are buried deep beneath the Earth's surface. For a few 100 million years, the heat and pressure of the underground have transformed these remains into fossil fuels such as coal, petroleum, and natural gas. We can find and extract these fossil fuels such as petroleum and natural gas from under the seafloor, and use it for electricity generation at the power plant.
6.2. Renewable and non-renewable energy sources. 1.
There are two types of energy sources. A. Renewable energy. B. Non-renewable energy.
Energy sources. Renewable energy.
Advantages. Able to replenish after used unlimited of times. Usually free and clean. Usually non-pollutant, produce minimal or no waste products. Low operation and maintenance cost. Disadvantages. High upfront cost. Low in consistency and predictability. Low in storage capabilities. Geographical limitations. Only can operate it in few selected locations.
Example.
Wind energy. Solar energy. Flowing water energy. Biomass energy. Geothermal energy. Tidal energy.
Non-renewable energy.
Advantages. Usually abundant and affordable. Usually cost-effective and easier to produce and use. High in storage capabilities. Non-intermittent. Can be turned on or off at any given time. No geographical limitations. Can be operated in any locations. Disadvantages. Cannot be replenished after use. Usually pollutant, and produce harmful waste products. Contribution to the global warming. High operation and maintenance cost.
Example.
Fossil fuels such as petroleum, natural gas, coal, nuclear energy. The need to conserve energy.
1.
We use energy every day for almost everything from lighting, cooking, heating and cooling room, transportation, healthcare, education, entertainment and manufacturing.
2.
Most of the energy that we use today comes from non-renewable energy sources, such as 80% fossil fuels, 10% biofuels, 5% nuclear and only 5% renewable energy such as hydro, wind, solar, and geothermal.
3.
Non-renewable energy like fossil fuels comes from sources that will run out, or will not be replenished. It is very important for us to conserve fossil fuels for the future, and at the same time, encourage the use of renewable energy sources. 4. Energy conservation is the effort made to reduce the consumption of energy, by using less of an energy service. This can be achieved, either by using energy more efficiently, for example using less energy for a constant service, or by reducing the amount of service used, for example, by driving less. Efficient use of energy.
1.
Efficient energy use, sometimes simply called energy efficiency, is the goal to reduce the amount of energy required to provide the similar products and services.
Example.
Fluorescent light bulb. Change to LEDs light, with higher illumination while using less energy. Home appliances. Change to Energy Star certified home appliances. Non-insulation house. Change to house with insulation, to reduce energy for cooling and heating. Petrol vehicles. Change to electric vehicles, or public transportation.
6.3. The importance of conserving energy sources.
The reasons why energy conservation is important.
1.
Reduce carbon emission. Energy conservation has the ability to reduce carbon emissions, by reducing the overall global energy demand, thus reducing the levels of fossil fuels being burned each and every day, in order to provide energy for homes, businesses and industry.
2.
Improve air quality. Energy conservation has the ability to improve our air quality, by cutting down the harmful gases such as carbon dioxide, that are pumped into the air as a byproduct during the process of burning of fossil fuels for power.
3.
Save money on energy bills. The more we conserve energy, the less we have to spend on energy bills. This helps homes and businesses cut costs, and allows any savings to be focused on more important matters. 4. Prolong non-renewable energy reserves. The greater our efforts in energy conservation, the longer we can prolong the reserves of non-renewable energy sources. This is of high importance, because fossil fuels will run out one day, but the Earth's population is growing rapidly, and the demands of global energy is likely continue to increase over the coming decades and centuries. The use and management of energy sources.
1.
Energy management is the process of monitoring, controlling, and conserving energy consumption in our day-to-day life. Reduce. Buy less goods and services. Travel less, or use carpooling. Do not overuse heater or air conditioner. Reduce food waste. Encourage work from home, instead of work in the office. Reuse. Cut down the use of disposable, or single-use items. Buy goods that can be reused, over and over again. Recycle. Recover back the waste heat energy, generated in the power plant, or industrial, via cogeneration process. Recycle as much as possible, the agricultural waste, domestic waste, and rubbish.
Happy learning